Hi guys, this is Sohil and today we'll be solving the problem of the day. So the problem states largest prime factor. It's a bit tricky because what we had learned in school was to take a loop from 2 to that number and then check divisibility. But this will surely pass the time limit, so we need to optimize the code. Another thing we can do is see. Okay, so what did we do here? Let's take an example uh, of 20. Okay, let's take 20 as an example. So what are we doing is that we are dividing this number with its lowest factor. So first we will take 2. Okay, so 2 is lesser than 20, right? And 2 is also divisible by 20. So this will be 20 by 2. That means the new n will have the value of 10. That is 20 by 2. Okay, so now what are we doing? We are decreasing the mean number by its lowest factor. In the second case, 10 is divisible by 2 again, right? So 10 by 2 results in 5. Now 5 mod I, that means 5 mod 2 is not equal to 0. That means I will become 3 here. Similarly, 3 won't work, 4 won't work, but 5 will work, right? That means in case of 5 we will get it, so it will be 2 and 5, which are the prime factors, right? Now we will use this logic, but there's a but. This code is faster than the previous one, right? But we can still optimize it. This might pass the test cases like this code, but we can still optimize the code for a faster and better complexity. Okay, so what will we do here? See, you have to think this mathematically. Let's take two numbers a b equals to n. Okay, now for this a and b, both of them to be maximum, this must be root n into root n equals to n, right? Like if both are same, then the maximum will be root n. Okay, now just think of something. If this root n is more than, like, if the value of b, okay, if the value of b here is more than root n, then the value of a has to be less than root n, right? We will use a similar logic here. What we will do is we will check for square roots. Okay, square root of the mean number, right? And what we will do is we will be getting the just lower factor, so that using that factor we can get the highest prime factor. So what we have to do is we won't be using this square root function here, rather we can check it by doing a square. Okay, so we did a square here, and there goes the similar logic. Okay, see, uh, let's take for example a bigger example, that is 50. Let's take 50 for an example. Okay, so in the first case, look carefully. 2 into 2, 4 is lesser than 50, right? and 2 is divisible by 50. Like 50 is divisible by 2, sorry. So n will store 50 by 2, that is 25. Okay. Now 25 mod 2. This is not 0, so this will move to 3. So I will have 3 now. 3 square, that is 9. 9 is lesser than the new value of n, that is 25. 9 is lesser than 25. But 3 isn't divisible by 25. Like 25 isn't divisible by 3. So let's go to 4. The similar thing will happen in case of 4. Now, in case of 5, 25 is lesser equals to than 25, right? So this will go in. Now, what will happen is 25 mod 5 is 0, right? Oh, another thing, we won't be dividing it by 2 here. I'm extremely sorry. This will be I. Okay. Now, what will happen is, see, I is 5 currently, and n contains 25. So this will be 25 divided by 5. So the new value of n will be what? 25 divided by 5, that is 5. Okay, so now the value stored in n is 5, and remember that the value stored in I is 5 also. So there will be a check in the while loop now. Like 5 into 5, that is 25, is lesser equals 5. This is wrong. So we will come out and we will be returning n here. Like n will be containing the greatest common, the greatest prime factor. Okay, that is 5. Like in this case. Okay. So I hope you have understood the code properly. Now let's compile and run to check if there is any error or not. Okay, now let's submit the code. Alright, so we have completed it, and thanks for watching, guys. If you have any doubts, then do tell me in the comment section.